Neural-machine translation. Three words that weren't really uttered together until about 4 years ago, and now they're words that are on the lips of every natural language processing researcher around the world. When did this happen? What does this mean? How well does this technology work? Hi, I'm John Tinsley, and this is the first in a two-part video series where I'm going to cover the history of machine translation right up to the state of the art today and all of the pieces in between. In this video, we're going to cover a little bit about how neural machine translation came about, what differences there are with it to previous approaches, and the impact that it's had both from a translation quality perspective, but also from a practical perspective. So first, let's take a step back and look at the history of machine translation, which can really be told in three epochs. The first one here is basically when machine translation started in the mid-40s with what was known as rule-based machine translation driven by US government research. The idea here was basically we wrote rules to determine how to translate between two languages and used dictionaries to fill in the words. And this was the way machine translation was done for quite some time, and actually the technology wasn't that popular and there wasn't a lot of funding for it. This changed in the late 80s, early 90s, through work that happened at IBM and Georgetown University, where statistical machine translation was developed. And this was an early application of machine learning to the idea of using data and statistics to learn how to translate between languages based on previous examples. And this was the state of the art for almost 2 decades, up until relatively recently when neural machine translation came on the scene. And the pace of development since neural machine translation has come on the scene has been rapid, to the point where we've already seen multiple iterations of the type of neural machine translation there is. So even in its short life, it has made quite a massive impact compared to the previous 60 or 70 years worth of research. So to focus a little bit on neural machine translation, what it actually is essentially the AI wave that we're seeing across many industries now, but this being applied to the challenge of translation and how we convert languages from one into the other. So let's take a little look at how it actually works without melting your brain with too much technical detail. But essentially, like all approaches to machine learning, we're using data to learn how to do something from previous examples. So we take let's take German to English, for example. We take millions of examples of previous translations between German and English. We put these into neural networks that then learn how to translate any new German input that it might see. It sounds easy, but obviously language is complex. Different languages treat different grammatical constructs in different ways. So in order to be able to account for that, we need lots of examples or lots of data. And this is why machine translation can be considered a big data problem. So how is it different from previous approaches to machine translation? Well, essentially they all look at data, but the algorithms for neural machine translation are not really that new. They've actually been around for quite a while, but what's changed is the compute power. Compute power has caught up so that it's able to actually process these vast amounts of data now in reasonable amounts of time. With statistical machine translation, it was pretty robust in how it produced translations, but it was pretty rigid. It was good at regurgitating what it had seen before and memorizing things. But neural machine translation is much broader. It has much better generalization capabilities. And the impact in that, in the short term, has essentially meant much better translation quality, much more fluent translations. So if you look at this example, this is a Russian to English translation example, where on the top we have the English translation from statistical MT, and on the bottom we have the English translation from the neural MT. So we can understand the translation from a statistical perspective. We can see that it says we couldn't do a video conference because of technical reasons, but the translation is clunky, it's not fluent, it's awkward. Whereas with the neural translation, we can see that it's much more fluent and it's probably a perfect translation. And that's the difference that we get with neural machine translation. Now, that's not to say that all translations are this good, but this is a good example of how much better it can actually be. Now at the outset of neural machine translation, in its kind of early stages of development, there were some issues, but for the most part, they've been ironed out, and we're going to address them in the second part of this video. But suffice to say now, from a practical perspective, for businesses, for enterprises, it's not a question of if they can use machine translation, it's a question of where and how they can use it in their organization. And that's been another big impact. It's basically opened up a world of new use cases to apply translation automation in the workflow of enterprises. And that's something that my colleagues are going to address in other videos in this series in terms of how neural machine translation has impacted industries like the pharmaceutical industry, the legal industry, intellectual property, and more. So please make sure to tune into those videos to learn a little bit more detail, and then don't miss the second part of this video where we're going to go into the weeds a little bit more on some technical details around neural machine translation. Thanks for watching.